Hi and Assalamualaikum, I'm Muhammad Fahim and we are group number 1. The title of our article is Determination of 8 synthetic dye in foodstuff by using green liquid chromatography. The topic is about chromatography, specifically about liquid chromatography using high performance liquid chromatography or HPLC. And now I will be explaining on the introduction and the objective of our assignment. High-performance liquid chromatography is often used to isolate mixture of certain substance to classify, measure or purify different compound of a mixture. The experiment utilizes green liquid chromatography, which is an environmentally cleaner and safer way of analytical method of chromatography that uses less organic solvent. Tartazine, indigotine, quinonal yellow, Pancho 4R, sunset yellow, brilliant blue, aurora red, and carmosine are the dyes found in many food items. Preparation of sample includes the process of dilution, separation using centrifuge, filtration, and drying before going through the HPLC analysis. Results are translated into graph based on the calibration curve and standard for each dye were used as guidelines for the analysis. Usage of food dyes are important to be known and to be analyzed for the sake of our own health and also to follow the standards without overusing the dyes in food items. Now I will be explaining on the objective of our assignment. Objective number 1 is to analyze 8 synthetic food color using green liquid chromatography, which is an environmentally friendly technique. Objective number 2 is to compare the amount and level of food dyes with the Iranian national standard using 4 different groups of food samples. Last but not the least, objective number 3 is to understand the usage of HPLC for quantitative or screening of food sample for synthetic food colors. Now we will continue with the chemical and reagent plus the apparatus used for the assignment.
The chemical reagent used in this experiment are distilled water, ammonia solution of 25%, hydrochloric solution of 10%, polymers absorbent, tartrazine, indigotine, quinolin yellow, Fonco 4R, sunset yellow, brilliant blue, allura red, and carmosine. As for the apparatus, there are pipette, 10 ml volumetric flask, 100 ml volumetric flask, beaker, test tube, membrane material filter, 20 cm paper, watch glass, water bath, filter funnel, filter paper, and our HPLC system.
Hi, my name is Nomasiza Matsuri, so I'm going to explain about metallurgy. This experiment divided to 3 parts, which is part A for sample preparation, part B is for thin layer chromatography, and part C for liquid chromatography analysis. So in this experiment we have 4 different samples. The first one is fruit juice, second one is saffron, the third one is colored rice, and the last one is cookies. For sample preparation, which is part 1, is the first step is transfer 10 ml of fruit juice into the volumetric flask and add 5 grams of saffron. Either choose colored rice and add distilled water until reach mark of volumetric flask. Then after that we mix the solutions. So in this part we must put sample into 3 different beaker and add 30 ml of NH3. After that we transfer to the centrifuge tube. Next step, we need to put the solution into the centrifuge. This step must contribute for 5 minutes at the speed 1800 rpm. Okay, we can get the result as 2 layers. What we need to do is must transfer the supernatant layer to the test tube and then add 2 grams of polyamide absorbent. Then we mix the solutions. To change the pH of solutions, we add the acid hydrochloric HCl to the test tube. To filter the solution, we use a 0.5 micrometers membrane filter. Then note that to make sure no balance in the test tube, wash it by using distilled water. The product that we get placed in the beaker then add 20 ml of NH3, then filter again. Repeat step 6 until 14 to get a result that's sample free from colors. The result that we get from the filter, we dry it by using boiling water bath. Then we filter again. What we need is the precipitate and then add 10% of HCl. Repeat all steps for all the sample that we have. For analysis, we go to the calibration curve by system. For part B is thin layer chromatography, that's SKA3013. So the size paper is prepared by 20 cm times 20 cm. So distance between the mark point is 2 cm. To run this TLC, the first thing to do is to ready the paper with the put sample on paper, then put the paper into the beaker, which is already have 10 ml of mobile phase, and cover with wash glass. For the part C, that is liquid chromatography analysis. The first one is prepare the mobile phase. That we need this to prepare mobile phase by dissolve 0.25 ml of tritons at 100 with 50 millimoles per phase per solutions. Then we filter the solution. This experiment of liquid chromatography analysis is run by the corner HPLC systems. That is example of full system of HPLC.
Assalamualaikum, my name is Siti Rabiatul Adawi binti Zamri. I will continue with result and discussion. As you can see here, there is table 1 which represent linear range coefficient of determination, part 2 ADI permitted colors, and percentage of each dye in studied sample. Table 1 shows us corresponding ADIs as set by the FAO or WHO and the European Food Safety Authority, the one that I circle. Plus, it also shows the percentage of each color in juice, colorized, saffron, and cookies. According to this test, tartarazine was the most commonly used color in all 4 studied groups. As you can see in table 2, tartarazine with a prevalence of 92% in colorized, 80% in juice, 60% in saffron solution, and 59% in cookie samples. Besides, table 1 also shows result for correlation coefficient that always more than 0.995 and closer to unity, showing a good relationship between peak areas and concentration. Detection limits of colors in the sample were also found to be satisfactory. Next, the table is table 2 that shows LOD, LOQ, and recoveries of each dye. Recoveries was estimated as the relationship between the experimental and the theoretical concentration, expressed as a percentage where experimental concentration divided with theoretical concentration multiplied with 100. The recoveries where n equal to 6 range from 93.5 plus or minus 0.9% to 99.7 plus or minus 1.2%. Plus, precision accuracy showed good standard deviation and show good recoveries values. For table 3, it shows mean of dye concentration in studied sample. From table 3, the highest mean of dye concentration in juice is carbamazine with a mean concentration of 208.57 mg per kilo, while in saffron is tartarazine with a mean concentration of 44.8. Plus, in both colorized and cookie sample, quinoline yellow had the record for the maximum amount with a mean concentration of 27.027 for colorized and 19.77 for cookies. But tartarazine was the most predominant among the dyes in all studied samples. This experiment, thin layer chromatography TLC and liquid chromatography analysis HPLC were carried out. But since TLC is not precise or accurate for determination, therefore HPLC was selected as the most suitable method.
Hi, I'm Nuzna. I'm going to present the conclusion. So from the experiment, we found that 8 synthetic food colors were analyzed using the green liquid chromatography. Those colors are tartrazine indigotine, quinoline yellow, ponco4R sunset yellow, brilliant blue, allura red, and carmozine. The amount and level of synthetic food dyes were compared with the Iranian national standards using the fruit juice, saffron, colored rice, and cookies as samples. It is shown that most of the analyzed samples in these studies were rejected, and just 7.5% of cookies, 30% of colored rice, 8% of saffron, and 12% of juice were approved. Quantitative analysis of colorants by using HPLC resulting from these studies has demonstrated that some manufacturers have used synthetic dyes to improve the appearance of their products against available standards.